Hey everyone, this is You'll Be Blessed here, making it clear, making it plain, opening up the heavens, for my teaching is like spring rain. And today I'm going to bring it to you in understanding the periodic trends, specifically in electronegativity. So you will be able to describe the trends in electronegativity in order to discuss the effects of the subatomic particles on the chemical properties of atoms, all right? And so the key to understanding how periodic trends work is that you need to understand that the interactions between the particles exhibit patterns. We're talking about the interactions between the protons in the nucleus and the electrons on the energy levels or on the energy shells. So let's begin. So electronegativity is a concept that is not equal in all atoms. All right. It has to do with the sharing of electrons, and knowing how strongly each atom attracts electrons helps us actually explain some of the physical and chemical properties, not just of the elements, but also the compounds that they form. All right. And so the scientist Linus Pauling developed a scale of numerical values that reflect how much an atom in a molecule attracts electrons. And so he called this number electronegativity. The highest value of electronegativity is 4. Okay, so it goes from a scale of 0 to 4, and electronegativity is the measure of the ability of an atom in a chemical compound to attract electrons. Okay, so this time we're talking about atoms that make compounds, and the electronegativity often results in polar molecules. So if you look to the right, there's this traditional water molecule with the delta plus and the delta minus, and it's showing you that the hydrogen atoms are slightly positive and the oxygen atoms are slightly negative because there is actually an uneven distribution of electrons, and it's due to this measurement that Pauling came up with called electronegativity. So electronegativity, in a sense, is basically a tug of war game, all right? And based on how hard these atoms are pulling electrons, like people pull on this rope in tug of war, it predicts the type of compound or type of bond that is between elements. And those three types are typically referred to as polar, nonpolar, and ionic. And of course, that will be its own separate lesson. So let us begin. We will now look at the electronegativity across the period. So electronegativity increases as you move across the period. And the reason why is because we are still looking at the 8 valence electron rule, the octet rule. And as atoms get closer to having that octet, they are, it's evidence that they actually are holding on to their electrons very tightly. They want to do that because they have more protons. As long as you are staying in the same row from left to right across the period, the adding nuclear charge actually attracts the proton, excuse me, it attracts the electrons closer to the nucleus. All right. So the more protons an element has before it gains more energy levels, the harder the pull is on the electrons from another atom. So let's dive into some examples. Which of the two atoms has a higher electronegativity? Is it going to be strontium with an atomic number of 38 or iodine with an atomic number of 53? Which one would you choose? I would choose iodine with an atomic number of 53. And the reason being, well, do you know the reason before I say anything? Well, the reason is because iodine is on the right side of the periodic table. Both of these elements are in the same period from left to right. They have the same number of energy levels. So because iodine has more protons, it has more nuclear charge, and therefore it is more prone to pulling electrons more effectively than strontium. All right, let's try another example. Which of the two atoms has a lower electronegativity? Is it going to be potassium with an atomic number of 19 or selenium with an atomic number of 34? Well, I chose potassium with an atomic number of 19. And so why would I pick potassium to have a lower a lower electronegativity? Well, again, we're talking about two elements that are in the same period again, same period from left to right. And so because potassium is on the left and because it also has fewer protons, so the real reason it has fewer protons, that means it has a lower nuclear charge, a lower attraction for electrons, and therefore it is not going to pull as hard on electrons as its cousin in the same row, which is selenium. All right, let's move on. So now we're ready to talk about the electronegativity as we go down the group, okay, going down the group. And so the electronegativity actually decreases as you move down the group. And again, this decrease tends to happen gradually depending on which group you're talking about. But why does this happen again? It is always because we're adding energy levels. And when we add energy levels, all right, we're starting with one, and then we're getting larger and larger and larger as we go down. So that means if we add energy levels, we're actually repelling the valence electrons. The electrons on the highest energy level are not feeling the effects of the nucleus, and so they are really kind of just out there floating around, waiting for something exciting to happen. All right. So let's go ahead and dive right into the examples. So which of the two atoms is going to have a lower electronegativity and why? Is it going to be beryllium with an atomic number of 4 or barium with an atomic number of 56? Which one is it? If you chose correctly, the answer is going to be barium with an atomic number 56. So why would I choose barium over beryllium? Well, barium is and beryllium are both in the same group. So we're talking about going down the periodic table. And that means we have to be talking about the energy levels. And therefore, since barium is towards the bottom of the periodic table, all right, it is in a higher period. That means it has more energy levels. And therefore, because it's readily pushing electrons away, it is not attracting them and is less likely to attract electrons when it's combined with another substance in a compound. All right, so let's keep it moving. Which of these two atoms has a higher electronegativity and why? Is it going to be antimony with an atomic number of 51 or nitrogen with an atomic number of 7? You decide. If you made the wise decision like myself, you highly anticipated that nitrogen would be the one having a higher electronegativity. So why would I choose nitrogen over antimony? Well, well, again, they are actually both in the same period. So we're talking about going down the periodic table, and we are always going to be talking about the energy levels when we go down the periodic table. So nitrogen actually has fewer energy levels, therefore, it is less electron shielding. It allows other electrons to get closer to it on the valence shell. And so, therefore, because those electrons are closer to the nucleus, it is going to try to pull onto electrons very tightly, all right, or very hard, okay, in this game of electron tug of war. So here we go. Here's our recap of electronegativity. As you can see, as you go from left to right, electronegativity increases and it decreases as you go down. All right. The dark represents elements of high electronegativity, while the light colors represent, or the light shading represents elements of low electronegativity, and white have an assigned value of 0. Okay. So before we wrap this up, I actually want to give you one more example to really test whether or not you're paying attention specifically kind of to this trend, especially the shaded. I love the shaded chart for a reason because it actually shows you some things that other periodic tables don't make obvious. Okay, so one more example. So which of the two atoms has a higher electronegativity and why? Is it going to be neon or is it going to be antimony? So neon, atomic number 10, or antimony, atomic number 51. Well, here's the trick. I really hope you were looking at this graphic because the answer is antimony. Yes, antimony. And some of you might be like, well, why antimony? Definitely why antimony over neon? Why does it have a higher electronegativity? Well, we said that elements that go down the periodic table, as we go down, the electronegativity decreases because there's more energy levels. And antimony definitely has more energy levels, but guess what? That doesn't matter because what matters the most is that there's a noble gas in here that does not like to react, and that's neon. All right. So The reason why it is not neon is because neon just does not have an assigned value. It has 8 valence electrons, okay? And I'm not saying that all noble gases do this, because if you look on this chart to the very, very right, I've even filled in helium, neon, and argon. Those three do not have assigned electronegativity values. And so that's just some extra information you may need to know or pay attention to, all right? So these are actually deviations from the trend. Deviations from the trend. But what about the rest of the noble gases? Well, even though noble gases don't like to react, okay, you can actually force some of the heavier noble gases to react, which is why they have electronegativity values, because these values only exist if you can form a compound or combine with another element. All right, so that wraps up the lesson for today. Thank you for tuning in to You'll Be Blessed Education. I hope you were blessed by this video, and if so, then I highly suggest that you click on the like button below, as well as subscribe to this channel so that you can receive future updates on content. Thank you, and have a blessed day.